Let's continue to check the edge classification. And we say, give the edge E equal to a tuple of U and V. U and V is classified based on a corner of V when the edge is first explored. Is a tree edge if V is white. That's true, right? So it means V, the next vertex, which is unexplored, and also they have the direct connection between U and V. In that case, that is a tree edge. And is the back edge if V is gray. It corresponds to the V. For example, let's say here, give example. This from A to B, this is the tree edge. Back edge, if from D, when you reach as far as you can from A to B, from B to D, right? And then from the D, you want to reach to the next adjacent vertex. And in this case, A is still gray because it didn't finish, right? We have to trace back, change the color. And since it's not, this color is gray, and you have this vertex U linked with this V, but this A, it is the ascendant of the D. So in this case, it means it have a cycle here, right? Can you see the cycle? So this is what we call the back edge. If E is E could be forward edge. If V, let's say, if V is black, let's say we use this one. This is U. This is a larger discussion, right? Let's erase this one. Erase this one. Let's use the different color to represent our current focus. Let's use orange. Okay. So we have U here and V here. So we say we already explored this branch and reach as far as we can and reach the leaves as early as possible and trace back. We finished this branch, then we want to explore this branch. And this is direct connection between U and V. We have an edge from U and adjust U to V. In that case, since D already finished the exercise and continue one, in this case, so D is the actual descendant of A. And in that case, this edge we call the forward edge, because it linked to its descendant, right? So that makes sense. And another type of edge is cross edge. If V is black, there is no descendant or ancestor relationship between U and V, then in that case, this is a cross edge. Let's use different color to represent that. So now let's use green. So this is U, this is V. We have this edge. And so we see that once you finish explore here, from C U to D, D is not descendant of C. You mean it's a child of C. We see the descendant corresponding to that is not direct. There's no direct. This is direct connection. Except this you could have more than one hop neighborhood, right? In this case, there's no more than one hop neighborhood from C to D. So in this case, we call cross edge. That makes sense, right? Forward edge corresponding to this vertex connect with its own descendant, and the back edge corresponding to it connected to its ascendant. And the cross edge corresponding to they just directly connected, but actually there's no descendant or ascendant relationship, and also they are different branch. They came from different branch. So this is called cross edge. Cross edge corresponding to the cross different branches. This edge connect the different branches. That makes sense. And no, for BFS, we will only consider 3 edges, but for DFS, we consider all the 4 edge types. In DFS of undirected graph, every edge is either a tree edge or back edge. So this is for undirected graph. For undirected graph, we only consider tree edge or back edge. We ignore cross edge or forward edge because if that's the direction make no sense, in that case, the both direction could happen. And we don't need to separate forward edge or cross edge. Definitely the cycle happen. Okay, now let's go to the next one. Next slide. And let's see here, we already take a look in the previous part of videos, and we already check the algorithm of DFS. Now let's use an example. And with the DFS depth first search, and corresponding to, we want to reach as further as possible. We go to the branch, we reach to the leaf as early as possible, right? So this is the main idea. And so let's start from A. Once you have A, we check based on the adjacent order, based on the adjacent list, right? We go to the B. It's the first step. We go to the B. And then follow the B, we go to the C. Right? Step 1, step 2. Then from the C, there's no way to go. You trace back to B and access D. So this is 3. And through the D, you try to access A. And now you see this is the back edge, right? This is the back edge. Not good. So also here, and D, with after you finish from D, you check A. This is the back edge. And when you check C, in this case, C already finished. And this is there's no descending relation. So in this case, this is the cross edge. This is a tree edge, right? What we need here is a tree edge. And then in this case, with after that, trace back, B finish, B finish, A is finish, and then you continue to check A and to check B, C, check F, right? So this is tree edge, and check F, and then you have C here. In this case, since this is the back, this is the what? This is a forward edge, right? Because F reach 2 is its own descendant, right? So this is a forward edge. Yeah, this is a forward edge. And then once you have the F, F, A, C, F to A, and in this case, A already finished is black. It's black. Oh, A is not black, A is the gray, so this is the back edge. And F to C with the forward edge, so you finish the F, F is black, right? So then you have that this part is unexplored one, so then you can check that and choose a random one, and then starting from here and to identify each specific edge. So we see this is cross edge, this is cross edge, and one of them is tree edge, One of them is tree edge, one of them is the other one, it is the back edge. Okay, just like this is same as what we discussed. And B corresponding to back edge. This one corresponding to back edge. C corresponding to cross edge, same as what we discussed. And this back edge and this cross. This should be from here. This is a little bit confusing, right? Because here we didn't explore F to A, but they do have one specific descendants here, right? So we see, the forward edge corresponding to A, F linked with its own the descendants. So we have to see this one later based on the exercise, right? Based on the who will be accessed first. So this one should be the forward edge. And then this is cross edge, this is the back edge, this is tree edge. Okay, I think this is clear. And also in this case, in the DFS also cast the whole graph into the two DFS trees, and they, between them is cross edge. And this DFS method can also work for undirected graph. It will work in the same way. It's just say only have two type of edges, back edge and tree edge. And you can take a close look later. Okay, so I think in this case we finish the two tree traversals. Let's take a look at some questions. The tree showed below on the right can be a DFS tree. For some adjacent list representation of the graph show below on the left. So this is the DFS tree for the list graph. It's true or not true. So we say starting from A. Let's check that. Let's use different color. We start from A, and you check C first, and check B, and from B you check E. In this case, check E, then you check D, and you trace back. So this is the tree edges. This part is correct. This tree edge, and then you trace back, access F, right? You access F. Just this also tree edge. That's good. Then you have check from here B. You have from F to B. From F to B, this part should be from E to B. F to B. This should be tree edge. This should be back edge, right? And then in that case, you finish F. You go back to here, finish E, and then you go back here, finish B, and from B you check A. This is also back edge. So from B to A, back edge is correct, and from E to F is cross edge, which is wrong, right? It's wrong. Definitely this is wrong because this undirected graph would not have cross edge. Okay, so this is the discussion for this video.